Okay, Assalamualaikum. We are now in chapter 5 doing the CPU scheduling. So here we will look at the basic concepts of CPU scheduling, scheduling criteria, algorithms, the multiprocessor and the real-time CPU scheduling. Okay, the objective of this topic is for you to know all the different CPU scheduling algorithm, know the scheduling criteria, and then apply the scheduling criteria, the various scheduling criteria in many situations. Okay, we start by a recap on the process states diagram, because this topic actually has a link to the process state diagram. Okay, however, for this topic, for this CPU scheduling topic, we will only be focusing on the ready and the running state. Okay, so we will be only focusing on the ready and the running state. So ready would mean processes that are ready to be executed by the CPU. So it can be many processes waiting here. Okay, and these processes will be selected by this scheduler and dispatch it to the CPU to be executed. Okay, so ready will be processes, so meaning that there are many processes that are in the ready queue, and running is the process in execution. There will be only one process in execution. Scheduler dispatch is actually the CPU scheduler which performs the CPU scheduling. Okay, and this happen in a cycle. Okay, so all this happen in a cycle, meaning that from ready to running, from ready to running, from ready to running happens in a cycle which consists of ready, running, and then it probably requires some I/O and then move back to ready. Okay, so this is what we call a process execution cycle. So process execution cycles actually consist of the CPU burst and I/O burst. CPU burst meaning that the process is being executed by the CPU, and I/O burst meaning that that process is serving the I/O request. Okay, so these are the basic concepts that you must understand about the CPU scheduling. Okay, so in CPU scheduling, maximum CPU utilizations is obtained through multi-programming, meaning that there are many programs in that can be executed. Okay, and it consists of the CPU and I/O burst cycle. Okay, process execution consists of a cycle of CPU executions and I/O wait. So it is a cycle. It repeats over and over again. Okay, and CPU burst distribution is of the main concern to determine the maximum CPU utilization. So in our topic here, in the chapter 5 here, our main issue is on the CPU burst distribution. Okay, it's the amount of time that the CPU executes. These are the scheduling criteria. You must remember this. You must actually know the definition for each of these. For example, CPU utilization. CPU utilization is to keep the CPU busy, meaning that the CPU is being used at any one time. Throughput is the number of processes that complete their execution per time unit. And turnaround time is the amount of time to execute a particular process. So meaning that how long a process takes time to be executed by the CPU. Waiting time is the amount of time a process is waiting in the ready queue. Okay, how long a process is waiting in the ready queue. That is waiting time. And response time is the amount of time for a process to receive the first request. to receive the first response. Okay, amount of time it takes from when a request was submitted until the first response. Okay, so meaning that from the time that process reach the ready queue until it is being processed. Next is the scheduling algorithm optimization criteria. So based on the earlier criteria, we wanted to maximize the CPU utilization, maximize the throughput, minimize the turnaround time, minimize the waiting time, and minimize the response time. That is the goal of the CPU scheduling. Okay. Finally, these are the scheduling algorithms that we will be looking. There are 5 here: first come, first serve, shortest job first, shortest remaining time, round robin, and priority. So we will be looking at each of these in detail. Okay, thank you.